Sir,
Yes.
so just to clarify that one, equation 7. Need
equation 7.
Next one, need only external force.
Okay. I am differentiating. My T is given here.
Okay.
Right? So I differentiate this with respect to firstly Q dot. When I do that, I get dri by dq dot and dr. This is ri dot ri dot. So when I differentiate it, my 2 will go away. I will be left with one ri dot and dri dot by dq dk dot. But then I use this identity equation 2 and replace this. Can actually cancel the dots as they call it. I can just cancel the dots.
Okay.
That's what so I have got this equation. But this is nothing but the momentum of the particle. Mass times the velocity. So I write down pi dot dri.
No, what is the meaning of the need only external force?
Which one?
Why only external force?
Equation number 8. Fi is summation of Fi is equal to need only external forces.
Here. Okay. Right now, what we have seen in the examples that we considered, if I put constraint forces here and calculate this quantity for the constraint expressions, the answer is 0.
Yeah.
Okay.
So I assume that my constraints are of that nature. For example, friction cannot be included in this. Okay. If there is friction, I cannot use Lagrange's equations. So then, let me remove this and start by discussing special theory of ranges. All students to read the first paper of Einstein, which is available now in many places. It is a paper which is quite simple to understand. The mathematics of it is not very difficult, and that's one of the classics of modern physics, which all of us, I'm sure, have enjoyed reading. So what is that book which is called? There is one book which has come, The Miraculous Years, I think. The Miraculous Year, 1905. I think there's a book which has come out which contains the 3 famous papers of Einstein. One, special theory of relativity, another one on Brownian motion, and which is so all these are there. Name? Miraculous. Einstein's Miraculous Year. Einstein's Miraculous Year. That's the title. And it has all the original papers with some comments by John Stachel. John Stachel. Stachel. I forgot. John Stachel. Okay. Now, let me firstly state the postulates of Einstein. And they are, one is, all physics laws of physics remain the same in any inertial frame. That, of course, is the same as what Newton said. But the next one is the crucial one. The velocity of light is the same in all inertial systems. So that's counterintuitive, because if some car is moving with some velocity v, and I am moving for me, and if you're moving with a velocity u, for you the car should be moving with v minus u. So for velocity of light, this is not valid. And one of the arguments which, though it is not so explicitly stated, which led Einstein to realize this, are the Maxwell's equations. So if I write the Maxwell's equation as there is one place where the epsilon 0, which is one of the constants which appear in and mu 0, and they are related by the relation c squared equal to 1 by mu 0 epsilon 0. Yes?
Yes, direct first postulate.
Pardon?
When you say the first postulate, laws of physics are the same in all
Same in all inertial frames.
There, do the laws involve, are the laws of electromagnetism?
Yes, moment it is involved,
Then
that's
you
how
need-
it's exactly. So, but at that time when Einstein stated it, it was not. That's exactly what I'm saying.
Oh.
So, precisely the point you're making. So, automatically there was a clue that if C squared is 1 by mu 0 epsilon 0 and mu 0 epsilon 0 is the same in all frames, you expect to see the same. But ultimately it is the experiments of Michelson and Morley which led to this result. So, given this, we have some very deep changes in our understanding of space-time, and let me start by doing that. So let me write down postulates. Obeyed are the same. In free space, I should keep in mind it is in free space that we are talking about. It's the same. Moment I have this, what is simultaneous in one frame is automatically not simultaneous in another. Let's see that. So, suppose I have a carriage of some length and let there be a light source at the middle of the carriage. So, there is a person associated with the carriage which I will call S dash, and the carriage is moving with the velocity v in that direction. And there is also an observer watching all this from ground. So, this person sends a light signal at some particular time t equal to t prime equal to 0. Since it is in the middle of the carriage, light traveling in this direction and in this direction will reach simultaneously here in this frame. So, light, when I am sending in, as far as this person is concerned, he will claim that the light which reaches here will be at the same time as the light which reaches here. Now, let me see this from the point of view of S. For him also, the velocity of light is c. It is not different. So, it is, if it is moving in the backward direction with c, but the carriage, the back of the carriage is moving front. So, if t back is the time in which the light reaches here, the carriage would have moved a distance vt, light would have moved a distance c t, right? That will be some length, I don't care what that length is, that length will be some length L prime. But the same thing would have been true here. To travel that length here, the carriage is now moving in that direction. So it will be C TA front minus V T F will be, because the length that he will move, I should write it as L prime plus V T. So this equation tells me the time light reaches there is given by L prime divided by C plus V. Whereas for front it will reach at C. So it will look like the back end will receive the light before the front end. So what is simultaneous in frame S is not simultaneous in frame S. This is the first important point which we realize. Lorentz transformation. Based upon this, now we have to mix time. Time is no longer an invariant concept, so I will now talk about Lorentz transformation. We will do it in the following way. I will keep a frame S. This is my x-axis, my origin, and this is say y, and z is coming out, and there is another frame S prime. All inertial frames moving with the velocity. This is O prime along the direction, along x direction with the velocity. This is what we will consider, and this is the very important point in dealing with relativity, especially doing problems, are events. You must always think in terms of events. Moment you think in terms of events, many of the problems in special relativity will get automatically resolved. Okay? So if an event occurs, that occurs for a particular observer at a particular place and at a particular time. So I should be able to measure the position of the event as well as the time in which the event occurs. This looks very deceptively simple when I say it. I will take examples in especially the homework problems. If you do not use this concept, you will go around in circles and you will take a long time to get to the answers. But if you use this concept, you will see it follows in two lines. So keep this in mind. And many of the problems in relativity can be resolved if you keep track of events. Okay. Now, how do I make measurement of an event in a particular frame? This operational definition should also be clear. I should have clocks which are synchronous. I'm only talking about one frame. I'm not talking about another frame at all. I have clocks which is synchronized with some standard clock at the origin, which I keep at every point in space. So, if a particular event occurs with you, you will have a clock and you will be able to record saying that the event occurred in my position at such and such a time. So that notebook is available. After all the experiment is finished, we compare notebooks and see where, at what time the event occurred. That is the statement for me for frame S. Same story would be for frame S dash. Okay? He will have a set of observers, he will have a set of clocks all synchronized, and he will say where is the event occurring. So the way I will say is the following. Event in S occurs at x, y, z, and time t. The same event in S dash now I want a relation between these spatial coordinates as well as time coordinates. Okay. I have assumed my velocity here of S prime with respect to S as d. I make the following assumption. I write down x prime as axx x plus axy plus axz z plus ax e prime as y prime, that's y prime is y x. I want to write this out clearly because many students do ask questions associated with this. assumption here. I have assumed that the two origins, when they coincided, you know, as this was passing, time t is equal to t prime equal to 0. So when x, y, z and t were 0, x prime, y prime, t prime, z prime were 0. Suppose this is not true, then I can just write down if x prime were equal to some 5 centimeters or some 5 meters, I could have just written 5 here, extra term. Whatever I can, that's a very simple way to take care of. If the two time, for example, t was equal to 0 and t prime was equal to 1 at the time they cross, then all I need to do is, when this is 0, just add 1 here. Right? That will make my t prime. Second, I want to ask you people a question. Why have I assumed a linear relationship? Why not a quadratic?
Light travels in the straight line.
Light travels in straight line.
Linear. Light travels in the
Straight line. If you're taking propagation of light, then it is r is equal to xi plus yz plus z.
But I can always write a quadratic equation for light also, x squared minus.
So we are trying to describe the position of the what event, and position of event is what it is always in linear form.
Why? You are right. That statement is correct. I only want you to defend it.
Because of light traversing straight line.
No, this has nothing to do with light now. I have two events taking place.
So when we are trying to observe any event, we are observing through the what light?
Simultaneously with the
No,
both times.
I don't. That's not what I said.
So
I have
this
kept clock. Please.
Is it one dimension? We are considering one dimension.
No, I have come three dimensions.
Three
I'm three dimensions. X, Y, Z, T. The reason is this. Supposing I have squared here. Let me try to invert the transformation. I will get plus minus. So, a particular event which I see, if I describe in x, y, z, t, I should get a unique answer of x prime, y prime, z prime, t prime. So, if I write a quadratic one, when I invert, I will get plus. So, that would mean that particular event is occurring at possibly two places, and I have no way to distinguish it.
Why do the correspondence cannot be there?
So, therefore, I need to keep a linear transformation. The inverse of the transformation is that is actually the reason. So, the other point of adding here, that also one can convert into a problem, and you can see how that happens. I'm closing that. Now, I'm going to make some simple assumptions. I assume x prime and x coincide. And then I assume y equal to y prime equal to 0 coincides all the time. The plane, these are planes. Y equal to 0 is the x, z plane. Similarly, I assume the x, z plane and the x prime, z prime coincide for all time. So, let's put that. Let me put y this equal to 0 and put y equal to 0. So, I get 0 equal to a y x plus a y z plus a y. This must be true for whatever be the value of x, z and t. So if this is true for whatever be the value of x, z and t, the only solution is a yx must be 0, a yz must be 0, a yt must be 0. Why? If I choose x equal to 0, z equal to 0, t not equal to 0, that would mean 0 is equal to ayt into t. But t is not 0, therefore ayt is 0. Similarly, I can choose x to be 0, but z not to be 0. So, therefore, this implies, is this clear to everyone? Ayx equal to ayz is equal to ay. Is this clear to everyone?
So So instead of saying what y is equal to y dash is equal to 0 is means assumption, we can say that while this is what moving along x-axis,
Right.
it means that y is parallel. Y is what axis? Y is parallel to y dash and z parallel to z dash. It means the position will remain same with respect to each
Which is
other.
what I am proving. Exactly. That's correct. So that
You are saying
assumption.
this assumption.
When you say y is parallel to y dash, again it's an assumption. So it's the same thing that is this fashion. Both are same. So what do I get for this equation? I get y prime equal to a y. Now, think of a frame which is moving with a velocity s double prime, moving with a velocity minus v. This is my y double prime and x double. I am having a frame. That is, instead of this frame moving in this direction, that frame is moving in the opposite direction. There, I have, it is moving in this direction. As far as y is concerned, it should not matter whether I am moving in this direction or whether I am moving in this direction. Both should be the same. So, I should get y double prime is equal to a, same ayy. It should not matter. Is this clear? Now, let us see what is the relation between s double prime and s. S is moving with a velocity v in that direction with respect to s double prime. Is the statement clear? S has a certain relationship with s double prime which is the same as what s dash has with s. Therefore, instead of writing it here, I can write this as y equal to a y. Okay? Because s double dash plays the role of s. So I just replace y double dash by y. This plays the role of s dash as far as this is concerned. So I have to write this. Please understand this logic. If it's not clear, I would like to repeat it. Okay, repeat it? Okay. Look at the relationship of s with s double dash. That is, s double dash is moving with the velocity v that way. So it's exactly the same state of affairs, the relation between s dash and s. S double dash plays what role? It plays the role of s. S plays the role of s dash. So, s double dash played the role of s. I replace it by y. S played the role of s dash. And so I replace it by. Is it clear?
Like change of position.
Pardon?
Change of position.
Exactly. So now I have here this equation. Let me call it A. Let me call this B. Let me call this C. Now, if I take A and C, what do I get?
A y y equal to y.
I get y equal to a y y squared or a y. And I choose the plus sign because if the velocity is 0, I want my y-axis and y-prime axis to be the same. And this answer does not depend upon the velocity, so choose. I can use exactly the same argument to show that a z.
So in equation C, it should be y prime or y double
Pardon?
prime?
Y prime.
Y prime.
Please.
Y
In
double
equation
prime
C,
is
y-
replaced.
it should be y prime or y.
What is the
in equation-
question?
In equation C, it should be y prime or y double prime.
What, a is plus minus 1.
In C.
Equation C.
See, why is this so? You want to understand C?
No, it should be y prime. It's okay.
Yeah, it's y prime. Because y plays the role of, let's look at these two. This plays the role of S, this plays the role of S prime.
Yes.
Why? Because S moves with a velocity v in this direction. So for all practical purposes, S double prime plays the role of S and S plays the role of S prime. So I write for this the coordinate coming from S, and for this I write the coordinate S prime. S prime plays role of S and S plays. Why? Because S moves with the velocity v with respect to S double.
I think the point is equation C should only involve variables of S and S double.
Yeah.
But now, as far as if this equation were valid, this equation has to be valid. Because this is like S. Okay? So I am writing the variable of any transfer. There is no distinction between the role S prime to S and S to S prime.
So whatever it is, equation number 1 connects S prime and S. Equation A connects S prime and S
Yeah, this connects S prime
and S.
to S. Correct?
Second connects S double prime to S.
No. Second connection what is?
S double prime.
Second one connects S double prime to S.
Yes.
But then I can read S double prime as S and S as S prime.
But equation.
I will repeat it again. Just forget S prime prime. Just forget S prime prime. S has a velocity with respect to S prime. With what velocity? V in the opposite direction. So that gives me a relation. I have written down y double prime is equal to a y y y. This is true for any two frames in which one frame moves with a velocity v with respect to that frame. This is a frame which moves with a velocity v with respect to that frame. In particular, that's exactly the relation I have between S and S prime.
Yes.
This frame moves with the velocity v with respect to that frame. So this is y should be equal to a y y. Is it clear? That's the problem. Oh.
I just had one
Yes.
question, if I'm not interrupting in this.
Yeah, go ahead.
No, today, I just need to know whether I'm right or wrong. Today, should we better phrase that first postulate as laws of physics are the same in all frames in flat space?
Well, I don't want to get into a full philosophical discussion on that. Essentially, it says in Maxwell's equations that another way is that once I have assumed relativity, then I prove Maxwell's equations are obeyed. So,
what I was trying to get at is, all this sort of gives the impression that special relativity is about Cartesian coordinate systems inertial frames. But special relativity is really about matter not being around. I just needed to know whether I'm correct about this.
no, I'm not fully understood it,
Sir?
but perhaps we can discuss this a little
Sir,
bit.
can I make some this correction here? In first
Yes.
postulate, all law of physics is same in all inertial frame of reference.
Inertial
If it is modified, if it is required, then we can do the modification. But modified form should remain same in all inertial frame of reference.
That is the correct law of physics.
This is correct law of what? Special relativity.
That. So, whenever I come up with a law, if it doesn't remain in the same in that frame, I claim that law is not
Then you
correct.
can do the modification. But
Yes.
modified form should remain same in all
That is,
frames.
the modified form is the law of physics.
Yeah.
Okay? It is the old non-modified form is not the law of physics. That required a correction.
Means sometimes some rules
It
is
will be valid in a
classical
certain
mechanics.
region. It will be valid in a certain region. Okay. So now let me proceed with the next step. Now, let a particle be rest. Consider now a particle at rest in S prime at origin. Then x prime equal to y prime is equal to z prime equal to 0 for all t prime. We also have x is equal to vt, because that origin is going with vt as far as s is concerned. So now I write the equation 0 equal to axx. I have my x prime is 0, axx x plus axy y therefore I have axx x is bt. No, I don't put y prime, again y prime z prime is 0 plus ax y y plus ax z z plus 3x. So from here I get ax y is equal to ax z is equal to 0. Right? And I get ax minus b. So I get this expression. I get ax b is equal to minus. This term is 0, by the way. Here, I should say 6. This is 0. Because y is equal to y prime, we have already shown, z is equal to z prime. So I have not shown that. So I come out with this is equal to I get that expression. So I get x prime. Now I apply the same logic that I applied earlier. I go to my frame S double prime. There the velocity v will change sign. So I write down x double prime is equal to axx times x plus. I use the same logic relating these two, so that gives me x is equal to axx times x prime. Till now I have not used the fact, the postulate 2 in which the velocity of light is just frames. Let me use that. And then I will just obtain for light I have x is equal to ct x prime. If I substitute that, then I get in this expression I get ct prime x prime. First equation I get ct prime equal to axx times ct In the second equation, I get C. And I can solve for this. Once I solve for this, I get AXX is the standard answer. A 1y root of 1 b square. You can just, you have two equations, you can get AXX from here and you get that answer. So from now I have the relation x prime is equal to gamma times x minus bt, and then I have x is equal to gamma times x prime bt prime. And I can substitute for x prime from this equation. I can, these two are just coming from there. I can substitute for x prime from this equation, and that gives me p prime. I can substitute for x prime in terms of x and t, so I can express p prime, and that is the standard p. So these are the Lorentz transformations, and I think that this is a good place for me to stop. We'll start from here. I have two more lectures, right? I will study the properties of Lorentz transformation. Some of the points which Professor Mukunda made will be made here. And
We'll come back